Hello, my name is Stavrola Kumu, and today I'm going to demonstrate to you the functionalities supported by Triabase's first version, also known as TriaStore. As you can see, we have already developed a graphical user interface for the database's application layer endpoints using the Swagger UI documentation tool. The code implementing both the endpoints and the API presented today can be found on my GitHub repository. The link is provided on the API here, as the link already says. Starting with the API, we see that the endpoints are grouped into model and metadata categories. Starting with the model category, we have endpoints that implement the functionalities of submitting a model, deleting a model, cleaning up a model, which has to do with model maintenance, and retrieving the model. Before we start trying these endpoints, let's go see what data is already stored on Triabase's blockchain network. And we shall do that by seeing what's stored on the word state database of one of the network's peers. And that database in our case is CouchDB. As we can see, there is a single model already ingested in our database, which has the identifier demo01. It has a single metadata page and 11 data pages, which are up to 10 megabytes each. Returning to the API, let's go update that model using the model submit endpoint. We click on try it out, and here we can change the identifier of the example. We have to use the same identifier as the one we want to, as the one of the model we want to update. And because we want to update some things, let's just make tag 1 to tag 111, well, because why not? And of course, the data were submitted are much less than the ones already stored in CouchDB. So we shall see a page reduction. And now we click execute. And we can see that the server of the application layer has returned an OK response, a success response, but that must be noted that it does not mean that our data have been successfully been stored on the blockchain. It means just that the transactions that do the model submission have been issued successfully. So to check whether the data itself has been successfully submitted on the blockchain, we use the model submit check endpoint, which actually returns the status of the submission request. Here we provide a valid token. This one has been already ingested on the blockchain so that we can, for demonstration purposes. And yeah, here we insert the identifier of the model we want to check the status of, the submission status of, and click execute. As we can see, our model has the submission transactions have been successfully completed because, well, the status is valid and there are no pending pages yet. And if we go back to CouchDB and hit refresh, we see that although the updating of the model has been successful, no data pages have been deleted, and that's normal. It is because our implementation uses simple overwriting of pages and adaptation of the metadata entry. So if we click on metadata, we only have one data page, which is this one valid data page, which is this one. We can see the data we have inserted as well. And the other pages are just trailover and unreachable pages, which we can delete using the model cleanup endpoint. We hit try it out, provide a valid token, the identifier of the model we want to clean up, and hit execute. And this is implemented using transactions as well, asynchronous transactions. So the OK here is returned with the exact same reasoning as the OK for the submission endpoint. So as expected, we also have a model cleanup check endpoint. And with the same reasoning, we provide our input, hit execute, and we can see that the cleanup has been successfully completed. Going back to CouchDB and hitting refresh, we can see that indeed the trailover pages have been removed. Returning to the API, with the same, if you want to delete a model, we go complete the delete metadata and all, not just trailover pages. We go to the model delete endpoint, hit try it out, provide our token, the model's identifier, and execute. Again, this response refers to the transaction issuing, delete transaction issuing this time, and we can check whether the deletion has been completed using the model delete check endpoint. So here we hit execute, and we can see that yes, our model has been deleted, and we can cross-check this by hitting refresh in CouchDB and seeing no model. So now let's move on to the metadata category. This category has 4 metadata querying endpoints. The simple metadata endpoint retrieves the metadata entry for a single model, while the other 3 return a list of metadata entries which match the query selector's criteria. Specifically, the metadata tags endpoint retrieves the metadata for the models having both the 2 tags provided, while the tag 1 and tag 2 endpoints retrieve the models which have the respective provided tag value. Now, let's go in just a couple of models for demonstration purposes. This one, using the model submit endpoint. Let's use the identifier demo02, tag 1, let's set it to car, and the second and tag 2 to detection. We hit execute. Then we go check whether the model has been successfully ingested. And we repeat for another model, we only need two to yeah, we only need two. And here let's just change tag 1, set it to bike, for example. We're detecting bikes, and hit execute. And again, let's check whether it has been successfully ingested. Not yet. Let's wait a bit. And we are good to go. Okay. Closing this one. Here, let's go test the metadata endpoint, which will retrieve just the metadata entry for a model of the model of our choice. Let's choose demo 02, hit execute, and here we can see the metadata entry that has been retrieved. Closing this one, we can move to, well, these three are pretty much identical. So let's go to metadata tags, tag 1. Here we provide a valid token, the page size we want, and when we say page size, we refer to the max number of metadata entries to retrieve, because maybe we have memory limits we want to take into our consideration. So, well, I don't have any, so let's set it to 100, although we only have 2 models in our database. And the bookmark, on the first time we use this endpoint, it has to be an empty string, so that the first results, the first set of results will be returned. And on later on usages of this endpoint, we shall provide the bookmark returned in the previous results, so as to, well, continue with the next set of results. Now for tag 1, let's set it to bike. This shall retrieve the model with the identifier demo 03, and indeed it has. If we set it to well, sheep, we don't have any sheep, so nothing will be returned. And let's go back. If we set it to bike again, here, this is the bookmark I've been referring to. So if we had more than 100 records here, providing an empty string will return the first 100. Then we have to copy this, well, all of it, and provide it in the subsequent call to this endpoint to retrieve the second 100 entries of this list. And we can actually see that using a similar example with tag 2, and only with a page size of 1, bookmark of empty, and here let's use detection so that both records are valid to be returned, but we will get only the first one on the list. And indeed, here it is, demo 02. So we copy the bookmark and provide it as an input to a subsequent call. And here it is. Now we get the second set of results, demo 03. And lastly, here we can just, well, here are the data modules used in this API. You can check them out if you want to. You don't really need to. Everything you have to know can be found directly by clicking these model links here, and it should bring it to you automatically, so you don't have to stress about that. And well, this was it. Thank you for your time. More information about Triabase, or more suitably TriStore as of now, can be found on the project's webpage and on the relative articles. May you have a nice rest of the day.